Hey guys, this is a 3D CAD model of a Nissan Silvia shifter trim. One of our viewers sent me his 3D scan data and asked if I could show how to reverse engineer this trim. This scan was captured with the Creality Raptor Pro. It's by far the most commonly used 3D scanner for automotive parts, judging from the number of projects people have sent me. I believe this trim is from the Nissan Silvia S14. The shifter trim actually comes in two parts, but I don't have the piece that locks the shift boot in place. I will walk you through the workflow for reverse engineering this trim in BricsCAD. Even though the viewer requested FreeCAD, the part is simply too complex to be modeled successfully there. This trim has curved surfaces on every plane, even though it was probably designed before 1998. Back when I was still in engineering school, there were already 3D CAD modelers running on Unix-based Sun Microsystem workstations. At that time, though none were available for PCs. And now, 28 years later, we are going to remodel this trim in BricsCAD. At the end of the video, I will also 3D print this part to see how it looks and feels in real life. The approach I will use to model this part is with the Loft command. I will crop the point cloud into a thin slice and then create the sketch profile along the cross sections, which are shown here with the white lines. Since the trim is asymmetrical, I need to model both sides. To speed things up, I have reduced the number of cross sections. It won't affect the quality when printing with an FDM printer, but if I were to print it with a resin printer, I would need to add more cross sections shown here in the magenta color. Here in Cloud Compare, it's tough to find any flat surface on this part, so instead I will align the tips of these standoff pins to the XY plane. Here in BricsCAD, this will be a workflow style tutorial. I will also be creating a slower step-by-step version for beginner, which I will post on my Ko-Fi platform. You can check it out there if you like to learn at a more relaxed pace. Now I'm drawing lines that I will use as references for creating the cross sections and cropping the point cloud. These lines will also serve to set up the UCS plane. To create the first cross section, I will crop the point cloud here, reposition the UCS plane, and start tracing with polylines. Next, I use the Add Bulge command to turn these straight lines into smooth curves. This will be the second cross-section profile. For this one, I simply copy the existing sketch and then modify it. And here's the one in the corner. Ideally, you should have 3 sketches at a right angle. Let's see how this turns out. For this cross section, I will simply mirror the sketch and then modify it. This cross section is placed closer to the previous one because I position it right where the curve begins to change. In BricsCAD, you can quickly adjust the curve tangency by sliding the node along the curve. This segment needs guide rails to force the shape, so I'm using splines for the rails. After creating them, I will experiment with the Loft command to see if more rails are needed. If more rails are needed, I will simply add them and run the Loft command again. Most car trims are modeled using the Loft command. Technically, Loft constructs the model by surface patching with sketch boundaries, but it creates watertight surfaces much faster than using the surface patch command with the profiles and rails. The only shape you can't create with a loft is dry junction. That one requires surface patching to model. When you place the cross-sectional sketches closer together, the surface comes out smoother and is less likely to show fasting. Now I have finished all the sketch cross-sections. The guide rails were created in segments and they are not tangent from one to another. So what I will do is retrace them as a continuous spline and then break it at the boundaries. The broken spline will keep its shape and tangency across segments. All the red lines shown here are retrace splines. Now that all the 2D and 3D sketches are complete, I will begin executing the loft command. Each loft segment is created as a separate entity. If one of them doesn't come out correctly, you can delete it, adjust the sketches, and run the loft command again. In the full tutorial, I placed more cross-sectional sketches, especially along the corners. I add 2 extra sketches for each corner to capture the geometry more accurately. In this section, the edge is standing out because I spaced the cross-sectional sketches too far apart, and I fix it by using the fillet command to round the edges. When there is nothing left to edit, I will weld all the segments together into one single body. Now the hard part is over. Next I will create and trim the edges, build with the loft command. If I try to model these edges directly with loft, it will add too many complications. It's easier to model them separately and then weld them to the main body. For the clips, I use UCS view to align their orientation so they can be extruded in the correct direction. Since each clip lies on a different plane, the UCS view command makes building them much faster. I use UCS view quite often when modeling clips and trimming edges. Now the modeling is complete. If you know your way around CAD, you can finish this in under 4 hours. However, the income from reverse engineering car parts isn't very attractive. You would typically earn around 100 to 150 US$ for modeling a part like this. In BricsCAD, you can export STL files at higher resolution by typing STL out in the command line and select high for the output setting. Here's the easiest part of the process of 3D printing. I will orient the part vertically so it achieves the smoothest surface finish. Next, I will inspect whether the support parts are floating too far from the main body and check if the 3 supports are strong enough. Slicers are getting smarter this day. There's almost nothing left to adjust manually. When you dry your filament, whether ABS, ASA, or PLA, support removal becomes much easier. I start by using a side cutter to separate the supports at their weak points, and this way when I pull out the larger 3 supports, they won't break the clips or stand-offs. But if your filament isn't dry, support removal becomes more difficult and you risk breaking clips. The cross-section in this area is spaced too wide. I can already see a few points for improvement, and I will put all of those together in the full tutorial. Once it's ready, I post the details in the comments of this video. Before this part can be put to the real use, you will need to apply a filler, a primer and top coating. Thanks you guys for watching. I'll see you in the next video.